Welcome to Optera's brief introduction to greenhouse gas accounting. Accounting for emissions is a growing priority for companies of all kinds. Regulation is playing a driving role, with some countries requiring companies to undertake a greenhouse gas emissions inventory and report those numbers. And large customers seeking to understand the emissions from their supply chain are beginning to require their suppliers to undertake greenhouse gas accounting. Investors and shareholders see climate risk and financial risk as being tightly intertwined, and want to have transparency over climate risk from the companies they invest in. And more companies are identifying that reducing emissions can also reduce costs in the short or long term. Measuring your emissions with a greenhouse gas inventory is the first step. To make sure that inventory can be accessed by interested stakeholders, it needs to be shared publicly. Many companies publicly report to an organization like CDP. Some also publish an annual ESG report for their organization. The next step then is setting emissions reduction goals in the form of a target. The most widely recognized way to do this involves approval by SBTi, the Science Based Target Initiative. And finally, achieving those targets requires creating an action plan and strategy for reducing emissions. While this may seem complex, fortunately, there's an established framework for emissions accounting called the Greenhouse Gas Protocol, which dates back to 1998. This framework provides guidelines, standards, tools, and trainings for calculating emissions, and it's continually updated over time. At Optera, we align our carbon accounting with this protocol. To make sure we're all on the same page, let's define some key terms. Greenhouse gases are gases that trap heat in the atmosphere. The primary greenhouse gases are carbon dioxide, that's CO2, methane, that's CH4, and nitrous oxide, N2O. While you may hear people refer to carbon accounting or cutting carbon emissions, it's important to note that carbon dioxide is not the only greenhouse gas. There are many other greenhouse gases. Three factors determine how much each greenhouse gas warms the atmosphere: how much gas is emitted into the atmosphere, how long the gas stays in the atmosphere, and what the warming potential for that gas is. Global warming potential, or GWP, is a number that compares the heating impact of greenhouse gases. Carbon dioxide has a GWP of 1 because it's the primary reference unit that we use when creating greenhouse gas inventories. Carbon dioxide is also the most common greenhouse gas that's released in the atmosphere. It accounts for nearly 80% of global warming. If you look at the chart here, you can see that methane has a global warming potential of 27.9. That means that 1 metric ton of methane is 27.9 times more potent than 1 metric ton of carbon dioxide. And a metric ton of nitrous oxide is 273 times more potent than a metric ton of carbon dioxide. Let's see an example of how this works. When you multiply the amount of a greenhouse gas by that gas's global warming potential, you get the warming impact of that gas relative to carbon dioxide. In greenhouse gas accounting, that's referred to as carbon dioxide equivalent, which you'll see referenced as CO2e. While dollars is the key reference unit in financial accounting, CO2e is the key reference unit in emissions accounting. Here, we're showing a simple calculation of a manufacturing plant's emissions and expressing it as a single number in metric tons of carbon dioxide equivalent. Say you know a manufacturing plant releases 20 metric tons of carbon dioxide, 5 metric tons of methane, and 1 metric ton of nitrous oxide. In order to convert all these greenhouse gases into carbon dioxide equivalent, which again is the main greenhouse gas accounting reference unit, you'll need to multiply carbon dioxide, methane, and nitrous oxide by their global warming potentials. For this example, it would be 20 metric tons of carbon dioxide times 1, 4 metric tons of methane times 27.9, and 1 metric ton of nitrous oxide times 273. Once you multiply each gas by its global warming potential, that gives you the CO2e, and then you would sum all those values together for the total carbon dioxide equivalent of your manufacturing plant. Now that you understand how to convert gases into carbon dioxide equivalent, here's your general emissions accounting equation for the emissions produced from an activity. We start with some activity data. Activity data can be characterized as the resource, often fuel or electricity, used to power that activity. For example, if you had a fleet of 10 diesel trucks. The activity data would be the amount of diesel purchased, perhaps in either liters or gallons, to power those 10 vehicles. Or it could be the amount of electricity in kilowatt hours consumed by a manufacturing plant or office. After we have our activity data, we then find the specific emissions factor for that activity. Then you multiply that specific emissions factor by the activity data. You can find emissions factors in a few different resources, like the EPA or UK's DEFRA. So take the example of the 10 diesel trucks. First, you must find the specific emissions factor for diesel. Then you would multiply your overall liters or gallons of diesel consumed by the 10 trucks by the diesel emissions factors. Usually, an emission factor has separate values for carbon dioxide, methane, and nitrous oxide. Multiplying the activity data by the emissions factor gets us the amount of each greenhouse gas produced. Then we do what we did in the previous slide. Multiply each gas by its global warming potential to get the emissions in carbon dioxide equivalent. This general equation really is the heart of emissions accounting. So remember, greenhouse gases include not just carbon dioxide, but also many other gases like methane, nitrous oxide, and others. Each greenhouse gas has a different warming impact. A gas's global warming potential is a number comparing that gas's warming impact to that of carbon dioxide. And emissions accounting uses global warming potentials to express emissions from different gases in metric tons of carbon dioxide equivalent, or MTCO2e. Thanks for watching.